Hi everybody, welcome to my channel. This is Shivkumar Reddy signing in. First of all, I would like to wish you Happy Ugadi. Many of our students had asked me to give one presentation on the estimation of material required for house wiring purpose. So in this session I am going to explain you how to calculate the list of materials required for a particular purpose like house wiring, and also the length of PVC conduit required, the different material required, and what will be the cost around, and finally including the labor cost, what would be the total investment for a particular application. So the objectives of presentation are, so once this topic is completed, you will be understanding the schedule of materials required for house wiring, and also the quantity and cost estimate for house wiring. So generally the following ratings and dimensions may be assumed, like fluorescent lamp is of power 40 watts, incandescent lamp 60 watts. These are the general wattage for different loads that we consider. For fan point we consider 80 watts, for socket 100 watts, for power socket 15 amperes 1000 watts. Of course it may vary from one author to another author. This is the general things that we consider. Height of the roof will be approximately 3.5 meters, and height of the switchboard 1.5 meters from the floor. Wall thickness 0.3 meters, and height of the main board and distribution board 2.75 meters from the floor. Some authors considered it as some 2.5 meters around. That depends upon the problem that is given for us. And height of the conduit 3 meters from the floor. So all these things are with respect to the from the floor we have to consider. Now the first thing is we have to design how many sub-circuits are required for installation. So for lighting load, we have to consider 800 watts or 10 points for each sub-circuit. So if the load is less than 800 watts or the number of points are less than 10, we have to consider only one sub-circuit for light loads. And when you consider power circuit, for 3000 watts or maximum points 2, up to 2 points or up to a wattage of 3000 watts, we have to consider only one sub-circuit. If it increases, we have to go for the second one. Now size of the conductor. How to find out the size of the conductor? Here size means it is going to represent the current carrying capacity of the conductor. So generally the current is going to be calculated. What is the total power divided by the voltage that is given? Generally the voltage will be 230 volts. So total power divided by the voltage will give you the current carried by the conductor, and depending upon the current capacity the size will be estimated, the size will be calculated. Normal size of the conductor for house wiring is going to be 1.5 square mm. So this is the general specification of the cable of size 1.5 square mm. Now this is the problem given for us. The objective of this problem is we have to estimate the quantity of the material and the cost required for the building whose plan is shown in the figure in PVC surface conduit wiring. So this is the problem given to us. Let me explain you the problem here. Here this is the entrance that we have, and two halls are there. This is hall number 1 and this is hall number 2. In hall number 1 we have This is one lamp, one fan and one tube light. Here we are going to be provided at the entrance the main board and distribution board, and this is socket, one socket here, one switchboard. So that's about the specification and the loads that we have in this hall. Come to hall number 2. Here we have one power socket is there. For this power socket we have been provided one switchboard and one lamp, one fan and one tube light, and one 5 ampere socket is provided here. And to control all these things we have been provided one switchboard. So depending upon the sockets and the loads, first of all we have to estimate the total wattage separately for light loads and power loads. So let us calculate. Depending upon, already we have mentioned in the previous slides that for lamp how much wattage, for fans like 80 watts, similarly for 5 ampere socket 100 watts. So all these things already we have specified. Based on that we have to make the calculations. Now let me calculate. The load details are totally 2 lamps are there. For each lamp we considered 60 watts, so put together it will be 120 watts. And for tube lights 40 watts each, 2 tube lights are there, so 80 watts. And fans, 2 fans each 80 watts, coming to 160 watts. Similarly 5 ampere sockets 2 are there, so each socket 100 watts and the total will be 200 watts. The power sockets are 15 amperes, one is there, and the capacity 1000 watts we considered. When you add all these powers, we are going to have the total load. Light load will be 560 watts, so 120, 80, 200, 360 plus 200, 560 watts for the total light load, and power load is 1000 watts. So put together, and the number of sub circuits are here. For light load it is less than 800 watts, so it will be of one sub circuit. Similarly the power load is also less than 3000 watts and 1 point is there, so this is also for required one sub circuit. So total number of sub circuits are, for light load one sub circuit, and for power load another sub circuit we consider. This is how we have to evaluate as a step 1. So what are the load details that we have, and we have to design how many number of sub circuits are required. Now let us see. Now let us go for the calculation of size of the wire based upon the current carried. For light load, the total current is total voltage. Total voltage already we have calculated it as 560 watts divided by 230 volts, that gives around 2.43 amperes, and 1.5 square mm cable is required for this current rating. So by this we have calculated what is the gauge of the wire required for this purpose. And similarly for power load, the total current is wattage divided by voltage, so already 1000 watts we have considered, divided by 230 will give you around 4.34 amperes, and for this 2.5 square mm PVC conduit is required, PVC cable is required. So this is how we have to find out the size of the wire depending upon the current carried by that cable. And so this is about the position of the main board, distribution board and switchboard. This one is of good importance to understand here. See, let me explain you. The height of the room is 3.5 meters, and horizontal run means the PVC conduit which is run in a horizontal way. Generally this will be situated at 3 meters from the floor. So here we are going to have a gap of 0.5 meters as a vertical up. So here you can see VU means vertical up. Generally this VU is going to be there when we run from the horizontal to the ceiling. So this is going to be considered when we are going to establish for fans. So for fans we have to move in the upward direction and onto the ceiling. Maybe it may be situated in the middle of the room, something like that. So here the vertical up is going to be considered whenever the ceiling fan is to be mounted, is to be established. And generally this will be of 0.5 meters because the ceiling height is 3.5 meters and the horizontal run is 3 meters. So the vertical up will be 3.5 minus 3, which gives you 0.5. So whenever we are going to have vertical up, that will be of value 0.5 meters depending upon the ceiling height and the height of the horizontal run. Now similarly, VD means vertical down. Generally the switchboard will be 1.5 meters from the floor level and the horizontal is 3 meters, so the vertical down will be 3 minus 1.5, which will give you the value of 1.5 meters. So all the vertical downs we consider 1.5 meters. So it is the distance between the horizontal run and the switchboard. And generally the main board and distribution board are going to be provided at 2.75 or 2.5 meters from the floor level. So here we have considered so many important points, parameters. What is meant by horizontal run and at what distance it is going to be situated from the floor. Similarly, what is meant by vertical up and what will be its distance from the horizontal run, that will be 0.5 meters. And similarly vertical down will be 1.5 meters. It is the distance between the horizontal run and the switchboard. So now let us consider the electrical wiring layout for subcircuit number 1. So here let us find out the horizontal runs here. First, from the main board or distribution board to this distance is 3 meters. So from here to here we are finding out the length of the conduit required. So from here to here this is 3, so we have specified 3 plus, and this cable this length is 4 and this length is going to be 4, so 4 plus 4, and another one is from this point, from this door to the middle point of this. So from here to here 3 and from here to here 1.5, and this is 4 and this is 4. So totally the horizontal run is going to be 3 plus 4 plus 1.5 plus 4. See whether all the boards are, all the switch boards and sockets all are connected or not through this horizontal run. So from here to here, and this length is considered, this length is considered, this is also being considered. So all the lengths are covered here. So these are the horizontal runs which are there for subcircuit number 1. Now vertical ups. So totally how many vertical ups are there here? From this is the fan point that we have. So from here to here, at this point we have one vertical up. So here also one vertical 2, and this is 3 and this is 4. Means from the horizontal run to the ceiling, and then to the fan, again from lamp to the horizontal run. So here this is 0.5 and this 0.5, like that 4 0.5s will come here, put together 2 meters, that is the vertical up and vertical down. So totally we have two switchboards, switchboard 1 and switchboard 2, and the switchboard 1 is, these switchboards are going to be located at 1.5 meters from the floor, and the horizontal run will be 3 meters, so 3 minus 1.5 is 1.5 meters. So the vertical downs will be 2, and that will give you the value of 3 meters. So totally the length of the PVC conduit will be 12.5 plus 2 plus 3, so put together 17.5 meters around. Okay, that we now let me tell you the electrical wiring layout for power subcircuit number 2. So here the horizontal runs will be this will be of length 3 and this will be of length 3, so put together we are going to have 6. And from here to power socket, so this is situated at middle of this room, that of length of this side 4 meters is there, so this will be situated at 2 meters from here. So 6 plus 2, that is equal to 8 meters. And we have one vertical down because switchboard 3 is included here. So from horizontal run to switchboard 3 we have 1.5 meters. So put together we are going to have 8 plus 1.5, that is equal to 9.5 meters for subcircuit 2. This is the PVC conduit length required. Of course we consider the wastage and all those things later on. So now let us find out the size of the main bus bars. So we are going to require the DPIC. So double pole iron clad of 15 amperes 250 volts. The size of the distribution board is 2-way. The rating is 15 amps 250 volts is required. And length of the PVC conduit for subcircuit 1 already we have calculated here. So 12.5 meters for horizontal runs, vertical ups for 2 meters and vertical downs for 3 meters. So put together it will come around, of course wall thickness is 0.3 we consider, so at two places we have to include this wall thickness, that will come around 0.6 meters, and total it will be 18.1 meters. And the total, if you allow 10% of wastage, this will come to 19.91 meters of the length of the conduit. So put together it will come around 20 meters for subcircuit 1. And depending upon this length, we have to calculate the length of the cable required. So we have already calculated that we require 1.5 square mm cable for this current carrying capacity, and generally the length of the cable required will be 3 times the length of the conduit we consider here. So put together 20 into 3, which will become around 60 meters, and there will be wastage whenever we do these connections, like at switchboards, junction points. We have to make some loopings around from one switch to another switch. So that when you consider that wastage also into consideration, that will be 10 to 15%. So that will come around 69 meters or 70 meters for this cable. So totally we require 70 meters for the cable. Now already we have considered the PVC conduit for the power circuit also. Horizontal runs 8 meters and vertical down 1.5 meters. Total will be 9.5 meters. And 10% wastage if you consider, we are going to have 10.45 or approximately 11 meters. So let us find out the current carrying capacity of 2.5 square mm PVC cable. That will be, already we have seen that 3 times the length of the conduit. So 11 multiplied by 3, 33 plus 15% wastage, that will come around 37.95. So you can take it as 38 meters. So that's about the item description, specification and the quantity. Of course here the quantity are not as per the previous one, so we have to change these quantities. Just only I am reading out the conduit pipe. So the cost is mentioned here based upon the present values. So here it is 25 per meter, so this will come around 700, like that. The phase, neutral wire, power wire. So this table you have to make as per your requirements that we have considered in the previous slides. And finally put together we are going to have a cost of 6,505 rupees for this equipment, and the labor cost is going to come around depending upon the load. Of course this also depends upon the choice we make. Here I have considered a particular example where the total labor cost is going to be around 3,210 rupees. So put together we are going to have a total of 9,715 rupees. So if you allow 5% for contingency, it will come around 485 rupees. So the grand total estimate is going to be 10,200 rupees or approximately 10,000 rupees for this purpose. So that's about the estimation of a house wiring, how we have to calculate for light loads and power loads, and the length of the PVC conduit, the size of the PVC cable, and also the length based upon the PVC conduit, how we are going to find out the length, and what are the different accessories that we are going to use and what will be the cost around. So this is about this presentation. Thank you very much. Please subscribe to my channel and do your valuable feedback. That makes a lot of valuable for me. Thank you very much. This is the Shiva Biram signing off.